Using the component tester on this Beckman Industrial 9020 scope, 20 megahertz scope, CRT, I'm going to be looking at a couple of capacitors that are going to be going into the power supply circuit of a quasi-complementary power amp of the Acoustic 260. The kind, can't really see it from this moment, that's sitting over there, but another one that's on the floor that needs some major component replacements. So I figure we'll look at some of the befores and then the afters, the ones we take out. So the ones I picked up, these are 100 microfarad 50 volts, or sorry, 100 microfarad 100 volts DC from mod amps, because finding axial ones like this is more and more difficult now. But mod amps had them, so we're going to go ahead and throw them on the component tester just to see how they look and do the after with the ones we take out, as I mentioned. So that should be a circle, relatively speaking, and it shows up here as a circle. More vertical. A vertical line is a dead short, and this has an ohms reading of, I want to say, 0.7 to 0.8 ESR. So if we short out the leads, straight short. And here's a couple of resistors from a signal tracer update. And these don't even read. So I'm not sure what that's about. Okay, that one reads a little bit. They're all out of tolerance. That one says it's open, I guess, if it doesn't read, right? Again, open. But they do show up on the ohm scale. Barely some movement there. Okay, anyways, back to, okay, so that's this one. That's one. And I put these on the capacitor tester a while back and kind of brought them up to voltage over some time. So there we go. That's another. And let's look at comparison wise a CAN one inside. So I have this ICO signal tracer that I've replaced some of the capacitors on, and I wanted to do this but I forgot about it. So we'll flip it over, kind of get it in here, see if I can get it into view. So the CAN filter capacitor is up here, and what we'll do is ground to case, right? So that's shorted. So there's a couple, there's four of them. There's a 20/20 and a 10 and a 10. So let's go. I'm going to say these two sides are the 10s or the 20s. I'm not. Okay, so the right side over here is that's a 10. That's the other 10. That's a 20. And that's the other 20. That's in the CAN. Now it's 8 volts. So that's what those look like. Now what about the new ones? Okay, that's the new one. And go to the other side. I'm trying to reach around here. And that's the other side. So there's resistors with them, so it may be reading the resistor with it, getting some of that flatness. So it's almost kind of the same, right? Let's take a look. 10. See how it's flat on the top. And the new 10. More round. Still with the flatness. Now the 20. That's the new 20. Old 20. New 20. volt 20. Almost the same, a little bit more round. So there's that. Yeah, so here we go. Now I got some 1 microfarads that are going to be going into the signal chain. Of the acoustic amp. So we'll take a couple look at those. They're going to be replacing some very high resistance ESR tantalums that are in there now that have just been cooked. So we'll go ahead and pull one of these out. All right. 1 microfarad, 50 volt. Not getting a good clampage. Surprisingly, these are stuck on there pretty good. They must have been in here for a while. Okay, positive side, negative side out. So that's a 1 microfarad. Is that a Nichicon? Are these Nichicons? A2224. Rubycons. These are Rubycons. And so that's what those look like on there. On the LCR meter, let's go. .97 nanofarads at 1 kilohertz. 929 nanofarads, so a little less than it's at 10K. A little less than a microfarad. At 1.59. Some of the 1 microfarad tantalums that are in the circuit right now are reading 40, 56 ESRs. At 100,000 hertz, so let's go up to there. That's 658 nanofarads at 100K hertz. So this is and just for comparison, turn that off. And one more comparison. I know it's a little out of whack, but we'll use this blue ESR meter that some people have to see what it reads. So on the blue ESR meter, this 1 microfarad reads 1.4, and I think this operates around 100 kHz is the audio frequency, or is that frequency used to measure on this thing. So with the blue, the LCR read about 1.6, 1.59, something like that. So once I get the old parts out, do another comparison and go back and forth and look. 1 microfarad electrolytic is going to be replacing the 1 microfarad tantalums. Tantalums were used because I guess the company had it back in the day. That's pretty much was the reason. They just had a bunch of them, and they were tiny. 1970s, late 60s.